Hey guys, welcome to another A-Level Maths Curriculum video. Today we're taking a look at the Binomial Expansion, or the Binomial Series, whichever you prefer to call it. And I'm including both first year questions and second year questions in this video, so it's just mainly to be used for exam revision. So what I will do is I'll highlight which questions in the description are for first year and second year. So the good news about this topic is you're given the formulas, so nothing to memorise essentially. All you've got to do is know which formula to use and basically how to use them. So it's worth pointing out here, this first formula, so a plus b to the n, well, that's for essentially if n is just a positive integer, okay? So if it's n is, okay, so like this question here, n is 10, so we're going to use this first formula, okay? The bottom formula here is to be used if n is either negative or if n is a fraction. For example, the square root, so that'd be a power of a half, so in that case we'd use this bottom formula. And this middle formula here, if you've not seen this before, this is how we just do the n choose r notation, okay? Now, what I would recommend is getting a calculator that can do this calculation for you. You want to just save yourself the time in the middle of an exam, instead of having to actually work this out by hand. But if you do need it, it's here, but I won't be using it for this video, as my calculator does perform it. And I think for A-Level Maths, I think pretty much all calculators will do this for you. So make sure you do know how to do it on your calculator. So this first question here then, in that case, we're using the first formula. So question 1. So we're using a plus b to the n. So let's just write down what a, b and n are for our question. So a is simply the first one, 2. B is the next term, minus x over 4. And then my n is simply the power, which is 10. Okay? So all I do now is I just plug everything in for my expansion. So the first part is a to the n, so that's 2 to the power of 10. Then we plus n choose 1, so n is 10, so it's 10 choose 1, times a to the n minus 1, so that's 2 to the 10 minus 1, so we times that by 2 to the 9. And then we times it by b, so we times that by minus x over 4. Okay. We won't do the calculation just yet, we'll do that at the very end. Let's just write down everything we've got first. And then we also add on the next term, so n choose 2, 10 choose 2, times, okay, so keep subtracting one off the powers you're going down, so it's 2 to the 8, and what you do is you add one to the next power here, so you go up with this one, so that's minus x over 4, all squared. Okay, and because we're only doing the first 3 terms, this is your first term, so that's 1. This here, that's your second, and this here, this is your third term. Okay, so that's second, third, and that's your first there. Okay. So all I need to do now is just plug everything into my calculator. So this really should be the easy bit. Just be very careful with your calculator. 2 to the 10, well that's 1024. Working out the second term now then. Well, 10 choose 1, well that's just simply going to be 10. We then times it by 2 to the 9, which is 512, so that's 5,120. And then we times that by minus 1 over 4, technically x, right? Okay, so what I've got then is minus 1,280 x. And then we do the same here with this third term. So 10 choose 2, do that on your calculator, times it by 2 to the 8, that's an 8, and then times it by, so this is x squared over 16. Okay, don't forget we're squaring this expression here. So this full expression for the third term will be positive. So we get plus 720 x squared. And that's actually it. Everything is in its simplest form there. We can't simplify any further. So in that case, question done, 4 marks. Okay, so let's take a look at a bit of a trickier example, where in this case here, we don't have an integer power. We actually have power of a half. Okay, so question 1. We've got the square root of 4 minus 9x. Well, I'm going to write that in index notation, so that's 4 minus 9x to the power of a half. And if you notice now, because n, our power, isn't a positive integer, in that case we use this bottom formula down here. Okay? So, let's just write down what x and n is. So in this case, x, well that's simply, in fact, before we do that, we've got to get it in the correct form. So I'm getting a bit too giddy, carried away with it. We need to get it in the form 1 plus x to the n. So notice here, we've got this 4, which is a bit of an issue. So we need to make that 4 become a 1. And to do that, all I'm going to do is I'm going to factor out that 4. So if I factor out that 4, that's 4. So all I need to do now is just factor it out from here. So that's going to be 1 minus 9x over 4, or 9 over 4x, whichever you prefer. Same thing, all to the power of a half still. But obviously take care here with the 4. If you pulled out this 4, don't forget we've got this power of a half here, so this will be also 4 to the power of a half, because the full expression is 4 minus 9x to the power of a half. But we know 4 to the power of a half, nice and easy, that's just 2. My full expression here is 2. 1 minus 9x over 4 to the power of a half. Okay. So, now I've got it in the correct form. Now we can write down what x is. So x is minus 9x over 4. And my n is just half still. Okay, so we don't do anything with that, just the power of a half. So all I do now is I use the bottom formula for this part here, my 1 minus 9x over 4 to the power of a half, and then at the very end we just times everything through by the 2. Okay, we times it by the constant on the outside. So if we do that then, well, I'm going to get 1, that's just my first term, plus nx, so n is a half times x, which is minus 9x over 4. So if I put this all in a bracket, this is minus 9x over 4 times a half. So that's just nx. So we need up to the term in x cubed. So this is your first one. This would just be x to the 1, x squared, and then we're going to have another one x cubed after it. Okay, so we've got a few more to do. So my next part here now, so it's n times n minus 1. So n is a half, so this is a half times a half minus 1. So essentially here, I'm going to do a lot of working. If you're confident with the algebra and using the formula, you can skip ahead a little bit. We divide this by 2 times 1. Okay, and then we times it by x squared, where x is minus 9x over 4. Minus 9x over 4, all squared. And we've just got one extra part here. We can't forget, we've got to do one extra term to get x cubed. Okay, so that'll give you the x squared term. Just got to do one more, so we'll do that underneath. So it's going to be, in this case, n times n minus 1 times n minus 2. So it's going to be a half times a half minus 1, and then a half minus 2. Okay, we divide that by 3 times 2 times 1. And then we times that by x cubed this time. So it's just minus 9x over 4 all cubed. Okay. So at this stage here now, we just need to start simplifying. Again, we've done all the hard work. If we start simplifying through here, I don't think I'm really going to have room, but we'll give it a go. I've got 1 here. We can't do anything with that, so that's just 1. If we've got minus 9x over 4 times a half, well, and don't forget we're timesing that by 2 as well in a moment. So what would that give us? That would give us minus 9x over 8. I'm going to have to times everything through by 2 in a moment. So let's deal with this part here. So this is a half times a half minus 1, so that's minus a half. So that's minus 1 over 4 in the numerator, and we divide it by 2, so that's minus 1 over 8, and then we're timesing it by minus 9x squared over 4. So what I'm going to do here, how do I do this without running out of room? Let's just write it out in full. Plus minus 1 over 8 times 81x squared over 16. And then finally, we just got the last term here. So don't forget this is a half times a half minus 1 times a half minus 2. Divide it by 6. So just plug all this on your calculator. What you should get here is 1 over 16 times minus 729 x cubed divided by 64. Okay. Now this full expression here, we need to times it by 2. Okay. So if you times everything by 2 here, so times through by 2, what does that give you? Well, 1 times 2 is 2. Minus 9x over 8 times by 2. Well, Well, that'll just give me minus 9x over 4. And again, just plug all this into calculator. You don't need to start doing this by hand. Do this on your calculator and then times it by 2. And what would that give you? That would give you minus 81 over 64x squared. And then finally, for the last term here, we get minus 729 divided by 512 x cubed there. Okay, and this part here, this is our final answer. Okay, this very last bit at the bottom. So it's very messy, like, see, I don't have a whole lot of room in keeping the formulas on the screen. But take it step by step. It's very methodical. As long as you like something where you know it's kind of always the same structure, you'll find this topic quite easy. Okay, so there we go, 5 marks for that. Another question here now, where this time we're working with a non-zero constant, so we don't actually have a specific number. We're just going to do it in terms of this constant. Now, later on in the question, we do actually work out the value of k, and then as a result, we can work out the coefficients for whichever one we want. So let's have a go at it. Question 3a. So the first thing to look at here is the power. Is it a positive integer? Well, yeah, of course it is. It's 6, right? So in that case, we're using this top formula here. So a is 1, my b is kx, and my n is 6. So in that case, I just plug everything in. The first term is a to the n, so that's 1 to the 6, which would just be 1 anyway. Then we do 6 choose 1. We times that by 1 to the 5. And then we also times that by b, which is kx. Okay. Again, notice the powers here. 5 plus this power of 1 here. Well, when you times them, you add the powers, so you get a power of 6 again. Okay. Just keep checking that as you're going along. Next one would be 6 choose 2. So 6 choose 2. We times it by 1 to the 4. And then we times it by this full expression squared. So it's kx squared. We're doing this up to what term? So the first 4 terms, so that's term 1, that's term 2, that's term 3. So we're going to have to do it one more time here. So let's see if we've got enough room. So it's 6 choose 3 times 1 cubed times it by kx all cubed now. Okay, so plugging everything in here now. 1 to the 6 is just 1. 6 choose 1 is 6, times by 1 is 1, and then we times it by kx. So what I get there is 6 kx. We've got 6 choose 2. Again, just do these on your calculator. Times by 1 to the 4 times it by kx all squared. So in that case, what I get is 15 k squared x squared. Okay, so that's that part. And then finally, if we do the x cubed term, that's going to be 20 k cubed x cubed. Okay, so that's my full expansion there for the first 4 terms. Now for part B, we're told the coefficients of x and x squared are equal. So can we then find the value of k and the coefficient of x cubed? Right, let's have a go with it. So if the coefficients of x and x squared are equal, what we're saying then is that 6k, that's the coefficient of x, is equal to 15k squared, the coefficient of x squared. So 6k is equal to 15k squared. So all I need to do now is just solve this for k. So if I subtract 6k off both sides, what that's going to give us then is 15k squared minus 6k is equal to 0. I can factor out a k here. I get 15k minus 6 is equal to 0. So you'd obtain 2 solutions here, but obviously due to the fact that k is a non-zero constant, we can't have this solution where k is equal to 0. So in that case, 15k is equal to 6, which gives us k is 6 over 15. Okay, so that's the value of k, which we can simplify if we want as well. That would be 2 over 5. And then for part C, we want to work out the coefficient of x cubed, the value of it. Well, this is nice and easy now. If we use the fact that k is 2 over 5, all we need to do is do 20 times k cubed, where k is 2/5. So all I do now is 20 times 2 over 5, which is k, all cubed. Okay, and if you just plug this into your calculator, what you should get here is 1.28. Okay, question done there. Okay, so sometimes you might be asked to work out little things like this, what the coefficients are, what the value of basically k is in this case. You know, it shouldn't be too tricky. Again, once you've done one or two of these questions, they're all pretty similar. Okay, so that's that question done there. We've got two more now, which we're looking at again, some of the more trickier ones. So in this case, we've included this one to show a negative power. So why is it negative? Well, we're going to write this in index notation again, but with it being 1 over 2 plus 5x cubed, we can actually write this as 2 plus 5x to the minus 3. Okay, that would be the same as 1 over 2 plus 5x all cubed. So in that case, with it being a negative power, we're using the bottom formula. And in that case, we need to get it in the form 1 plus x to the power of n. So how do I get it from 2 to 1? Well, we factor that 2 out, just like we did previously. So this is 2 lots of 1 plus 5 over 2 x to the minus 3 here. And remember, we pull that minus 3 out to the front here. So it's 2 to the minus 3. So it's 2 to the minus 3. But remember, that would just be 1 over 8. Okay, so that's 1 over 2 cubed. So if we just erase that, and we just write it as 1 over 8. So that's 1 over 8, because we write that as 2 to the minus 3. So 1 over 8 times 1 plus 5 over 2, x to the minus 3. So all I do now is we use the expansion given at the bottom. So we times the whole expansion by 1 over 8. And we're doing this up to the term in x cubed. So the first term is 1. Again, let's write down n and x. So n is my power, which is minus 3. And my x is just simply the 5 over 2. Okay, so plugging everything in here now, what I've got then is plus minus 3 times 5 over 2x. That's my nx. Then we do plus, so I've got n times n minus 1, so that's minus 3 times, subtract 1 off this, which is minus 4. We divide that by 2 times 1, so 2. And then we times that by x squared, so 5 over 2 x all squared. Okay, so that's the x squared term. And then if we work at the x cubed term, we should have just about enough room. So it's going to be minus 3 times minus 4 times minus 5. So then we just keep subtracting 1 at each stage. We divide that by 3 times 2 times 1, so 6. And then we times it by this whole expression here cubed. Oops, that should be on the outside. There's a power there. Okay, so again, we've done all the hard work here. All we need to start doing now is just plugging things into the calculator. So that's 1 over 8 times 1. If we start simplifying here, in fact, if I actually multiply through, it might make it a bit easier. Oh, so what's going on? What's it doing? Why have I lost my pen? See, that's the issue. I can't see the pen with this formula in the bottom corner. Right, okay, so what I'll do is multiply through by 1 over 8 each stage. So 1 over 8 times 1 is 1 over 8. We've got 15 over 2. So if you times that by 1 over 8, that would be minus 15 over 16x. So that's that x term done there. Minus 3 times minus 4, so that would be 12. We divide it by 2, so that gives us 6. We then times it by 25 over 4x squared. So that would be 1 over 8 times 150x squared over 4. So I'm going to times it through by 1 over 8 at some moment, rather than trying to do it all off the top of my head, plus 1 over 8 times minus, so that would be minus 1,250 x cubed divided by 8. Okay. And again, just working out this final line of working here, these two terms won't change, so 1 over 8 minus 15 over 16x. 150x squared over 4 times by 1 over 8. So simplifying this fully now, this would be 75 over 16 x squared. And then finally, minus 1250x cubed divided by 8 times 1 over 8. That will actually give us minus 625 over 32 x cubed. Okay, so be consistent with your working. I'm doing it a little bit haphazardly by timesing through by these two by 1 over 8 and then leaving the 1 over 8 on the outside. As long as you're confident with the algebra here, you shouldn't be too bad. Like I always say though, use your calculator to its full strength. You've got it in the exam, so you know, don't try and do it off the top of your head like I start doing through the middle of this. But you should be okay. And there we go. So that's our final expansion here at the bottom. Okay, so 6 marks for that. Not too bad. And then we move on to the very final question here. We want to find the binomial expansion of the square root of 1 minus 8x. And then we want to show that when x is 1 over 100, the exact value is root 23 over 5. And then we're going to substitute 1 over 100 into our expansion in part A to obtain an approximation to root 23. So let's have a go at this. Again, quite another standard exam question. These little parts are quite nice and easy. So as long as we can do the first part, the second two parts are nice and easy. So we're using here index notation. So this is 1 minus 8x to the power of a half. So again, power of a half is not a positive integer. So in that case, we use the bottom formula. Now because we're using the bottom formula here, let's just write down what x and n are. So x, and just double check whether it's in the right form. Now this one is quite nice because it's already in the required form. It's 1, okay? 1 here, so we can start working straight away. So x is minus 8x, my n is a half. So this is going to be quite a nice one because we can start using the expansion straight away. So the first term is always 1, plus n times x, so a half, times minus 8x, plus, so it's n times n minus 1, so that's a half minus 1. We divide that by 1 times 2, so 2, and then we're going to times that by x squared. Okay, so we times that by x squared, and we're doing up to the x cubed term, so we've got to do this one more time. So if I just do it underneath because I'm running out of room, so it's going to be a half times a half minus 1 times a half minus 2. Half minus 2. We divide that by 3 times 2 times 1, so that's 6. And then we times it by minus 8x all cubed. Okay, so we're just using the formula there. So we need to work at this out in its simplest form. So doing that, that's going to be 1. A half of minus 8x, that would be minus 4x. A half times, well, that would be minus a half there, so that's minus 1 over 4, and we divide that by 2, so that's minus 1 over 8, and then we times it by 64x squared. So simplifying this, that would give us minus 8x squared. And again, just do the same here with your calculator, working this out. What you should get if you do everything correctly is minus 32x cubed. Okay, so that's just our expansion in its simplest form. So we can't go any further with part A then. So if we work out part B now, we want to show that when x is 1 over 100, the exact value of the square root of 1 minus 8x is root 23 over 5. So what we're doing then is we're using this here. We're using the square root of 1 minus 8x. But don't forget we're using the fact that x is 1 over 100. So what does that look like? Well, that's going to be the square root of 1 minus 8 times 1 over 100, so 8 over 100. So that's that part there. Simplifying this bracket then, so this is 100 over 100 minus 8 over 100, so I get the square root of 92 over 100. And then at this stage here, we're just doing some basically GCSE maths third work, simplifying this at each stage. So this is the square root of 46 over the square root of 50. You can write all as one square root if you prefer. But the reason I'm splitting it up here is because in a moment we can simplify this again. So this would be the square root of 23 over square root of 25. And then at this stage here, we can't do anything with the square root of 23, but the square root of 25 is 5. So what I actually get then is the square root of 23 over 5 as required in part B. Okay, so as required. Now, I'm being a bit sloppy with my working here. This should actually all be over 1 square root, so if I just do it clearly down here, this is the square root of 46 over 50, which then gives you the square root 43 over 25. And then we split it up into 2 separate square roots like that. Okay, so I'm just being a bit sloppy with my working there, so ignore that. That's correct there though. Okay, so that's part B. And then for part C, if we just do it at the top here, I know it's a little bit all over the place, but we're on the very last question here now. So we're going to substitute this into the expansion to obtain an approximation for root 23. So what would that be in this case? Well, if root 23 over 5 is equal to the exact value of this, what we can do then is use our expansion. So we're using 1 minus 4x minus 8x squared minus 32x cubed with x equals 1 over 100. So let's do that. So x is 1 over 100. So substituting that into our expansion, this is 1 minus 4 lots of 1 over 100. You can write this as 0.01 if you prefer. It's completely up to you. I'm going to keep it as 1 over 100 for now. Minus 8 lots of 1 over 100 squared. Minus 32 lots of 1 over 100 cubed. Okay, so I'm running out of room. 1 over 100 cubed. Now at this stage here, what we need to do is we need to plug this into our calculator and work it out. Okay, so if you put all of this into your calculator correctly, what you will get here is that this is equal to 0.959168. Okay, so at this stage now, what we know is that the square root of 23 divided by 5 is equal to this expression here. So that's 0.959168. So in that case, to get the square root of 23, all we do is we just times both sides by 5. So square root of 23 is equal to 0.959168 times by 5. And let's do that. I normally do the calculations beforehand, but I didn't do this one. So 0.959168 times 5. And to 5 decimal places, my calculator just gives it exactly as that. So that gives us 4.79584 there. Okay. And if you put in the square root of 23 on your calculator, obviously you get a quite nice approximation here. So this is what I get on my calculator. 4.79583. So like you can see, it's pretty close. So yeah, so that gives you a good idea. So always plug in the actual square root that you're working out just to get an idea. If it comes off massively different, just double check it. Something's probably gone wrong. But as they're so close, that's looking pretty good there. Okay, so that's the very last question there. I think it's been a bit longer than I anticipated, but I hope it's helped. You know, it's not one of the trickiest topics, but it has a lot of little traps in it that you've got to be careful of. So I hope it's helped. If there's any issues, just leave a comment down below. Cheers.